My name is Becnel, and I'll be explaining a word problem related to acceleration, position, velocity. The acceleration of a certain rocket is given by ax equals bt, where b is a positive constant. Step 1, find the position function. If x is equal to x0 and vx is equal to v0 at 0 seconds. Step 2, find the position and the velocity at 5 seconds. If x0 is equal to 0 and v naught x is equal to 0 and the constant b is equal to 3 meters over seconds cubed. Step 3, compute the average velocity of the rocket between the time intervals 4.5 seconds and 5.5 seconds. At 5 seconds, if x0 is equal to 0 or v of x equal to 0 and b is still equal 3 meters over seconds cubed. Next, compare this average velocity with the instantaneous velocity at 5 seconds. Step 1, find the position. We know that acceleration is equal to the derivative of velocity with respect to time. So velocity is equal to the integral of acceleration, which is 1/2 times b times time squared plus c, where c is equal to velocity function at 0 time, which is the same as v naught x. Therefore, the function of velocity is 1/2 times b times time squared plus v naught x. Next, the position. We know that position is equal to the integral of velocity. So the position function would be v naught x plus 1/6 times b times t cubed plus c, where c is equal to x position at 0 seconds, which is x0 up here. So the position function would be v naught x times t plus 1/6 times b times t cubed plus x at 0. Step 2, find the position at 5 seconds and velocity at 5 seconds, while having t equals 5 seconds and b still equaling 3 meters per second squared cubed. Velocity at 5 seconds is going to be 62.5 meters, and velocity at 5 seconds is going to equal 37.5 meters. After plugged in, all these go to 0, and it just leaves you with a simple function. Step 3, find the average velocity. We know that average velocity is equal to x final minus x initial over t2 minus t1. So the average velocity is equal to position at 5.5 seconds minus position at 4.5 seconds over t2 minus t1, which is 1 second, because there's a 1 second difference. So that gives you over here position at 5.5 seconds is 83.1875 meters. So you plug that in right here, and then position at 4.5 seconds is 45.5625. Those subtracted is 37.6, which is about 37.6 meters per second, which is the average. And step 4, compare the instantaneous velocity to velocity average, where instantaneous velocity is equal to 37.5 meters per second and average velocity is equal to 37.6 meters per second. They are only close because the reference was 5 seconds, and that's the middle of the 2 given time intervals for the average velocity. Thank you.